Let's look at this this piecewise function and determine if the function fx is continuous at x equal to 0 and x equal to 2. Well, first of all, let's look at x equal to 0. This is now here. Let me just get another color. Well, x equal to 0 is there, so the corresponding y value is going to be -1, okay, at x equal to 0. Now, to determine if this piecewise function is continuous at x equal to 0, well, we'll have to do those tests. And first of all, we see, well, we ask ourselves, does this exist? Does x equal to 0 exist? Well, it does, but the answer is -1. Okay, and now we must ask. This is the first question. The second question we need to ask is if the limit as x approaches to 0 of the fx, does it exist? Okay, so to determine that, we must determine if the limit of x as it approaches 0 from the negative side of fx is equal to the limit of fx as the x approaches 0 from the positive side. Now, clearly here, you'll see as the x approaches 0 from the negative side, the y value is 1. And as the x approaches 0 from the positive side, the y value is negative. So it doesn't exist. Okay, so it doesn't exist. So it doesn't exist because the limits differ. And therefore, you don't even need to do the third test, which says the limit, the limit of fx as the limit there as the x approaches to 0 must be the same as f0. You don't even need to do that, because if this test already fails at the second point and it doesn't exist, then you know it's already not continuous at x equal to 0. So it's at x equal to 0, not continuous. Okay, now let's look at, well, this is now for x equal to 0. So let's look at x equal to 2. Let me just get another color. X equal to 2. Is it continuous at x equal to 2? Well, remember, there's the x equal to 2. Now, I'll just do it here on the side. Well, first of all, the thing is the first test. Let's put 2 into the fx. Now the corresponding y value is going to be 1. So as x is equal to 2, the y is 1. So f2 is 1. This is now the first test. Now remember the second test. The second test is that if the limit, does the limit of x tend to 0 or tend to 2 of fx, does it exist? So I'll just try to write it here. So does the limit of as x approaches 2 from the positive and negative side for fx exist? Well, it does, doesn't it? Because here you'll see as the x approaches 2 from the negative side, the corresponding y value is -1. And here, if as x approaches 2 from the right hand side, the corresponding y value is -1. So the limit of fx as x approaches 2 does exist. So you have the first test for continuity is there, the second is there, but the problem with the third test is that, well, the limit, this limit as the fx, let's put my I in there again, as the limit of fx as the x approaches to 2 is not equal to f2, because remember the limit of fx as x approaches to 2, the value of that is this -1, okay, but the limit, but f2, the function at x2, its value is 1, so these two are not the same, and therefore it's not continuous. And we call this type of discontinuity, we call the removable discontinuity because you have this point that was removed. Here, at the first continuity test, this is a jump discontinuity because you can see it goes to one point and it jumps suddenly to another point. So that's a jump discontinuity.